So you guys already know me, so I'm not going to. Quickly about the center, we have a vision which we set up in 2022. It's to connect maps, apps, data, and people to make an informed public health decision-making process. That's our vision. And who are the people behind it? Quickly, there are close to 50 people in our team. They're based in different parts of the world, and they really run the show. It's really, 3 years ago, we were 3 people in the center. Now we are 50. I just want to say that the demand which is there outside, I just want to point to the amount of demand which is generating in this area, in the area of health, especially after COVID, it is phenomenal. We are also decentralizing. So we have recently launched a center in Somalia, where there's a need for us, where there's challenges for us. WHO works mainly in these difficult situations, right? And also we have established a center in Turkey. So we have a geospatial hub, and we just launched it in November. So for partners who are in Europe, this will be a great place to work with them. Might be, if it's talking about health, might be this map is very familiar, right? John Snow map. Everybody knows this map. So this gentleman in 1854 did this work. I don't know what he envisioned or what did he want to get out, right? We very less know, but he spoke about that. And then I saw a nice spatial analysis by a student. I thought I'll show it here. This was very recently, somebody did it. So they put the water points, they put the places where people died or infected and people died. So then they said there's a correlation between this. So this is happening. And then what is the current advancement what we have after all these Google Maps and things which started into our palms and our maps and things? I think this is what is possible now. And the future is definitely, I'm thinking from our side, is there's a lot of internets of things happening, and I think these are all going to be related, right? And it's going to impact us a lot. I'm just putting in front of, not that you guys, I'm preaching to the quorum, you guys know it best, but we are thinking from WHO that these are going to impact us. For us, it is very important to know that one circle where a person lives, because we are a service delivery, right? Universal health coverage. We have to deliver our services to them or map the cholera cases. 1854 to now, we need to see how many outbreaks we are actually able to map the cases individually. Not much. Not much. Actually, we need help. We need to do this more vibrantly. Okay, this map was done by somebody else. I think it's the University of Columbia. They did this work, and WHO did this PHSA analysis. So we are catching up, right? We are catching up. Okay, this impact on climate change, which is happening on health. How do we catch up to this? So this map, they asked, how can we actually use this? And we said one possible way is to let's overlay our cases, cholera cases and things. See, is there a relation during that period of time? This is one simple thing we showed to our management to do the advocacy on health and GIS. But 50 people in this room will have 50 different ideas, right? How this data can intersect and how these can work together. Morning when we are seeing the presentations, there's so many things which we do not know, which exist there outside. Terabytes of data available there outside. How can we bring it to our use is the question here. I'm just throwing random of things here to see what are the areas we work. We had been asked to support the Horn of Africa food and drought insecurity. Maybe others are going to talk more about it. But where does health come in this? Somebody, an expert told me, it is between malnutrition and death, right? First you have the famine or food insecurity. You don't have death at the time immediately because of the diseases. But the moment you push to the edge, then you have malnutrition, then it goes to the death. Between these two, there are so many diseases and outbreaks which comes in and goes there. That is what we are interested in that. I think Claudia nicely said in the morning, always we are doing firefighting, right? We're always saying, oh, there is this is not the first time in Horn of Africa. There's so many times food and drought insecurity incidents have happened. It's a wave of things happening. But once again, okay, let's go and do help now. But what we are interested is, because there's acute droughts in certain areas, people are actually moving out from there to other areas where there's greener pastures and where there's better water and food. So it means for us is the impact on our health services, the impact of the load on our essential services which we are trying to deliver. If we do not map them, if we do not see the population migration, if you do not see that pattern to us, we'll be blindfolded, right? The people on the ground level say, hey, we have little more people coming. By the time, it'll be too late for us to actually intervene and help them. The recent floods in Somalia, I don't know if you guys, Space Charter was activated, and there was a lot of, recently I was in Somalia also, the Prime Minister and everybody, there were a big delegation of people going to the field and things. Simple question, how many health facilities are flooded? And immediately we worked with UNICEF, USA and others. We tried to get their information and put it. But this map was afterthought, and later that we did that, because it is possible to already predict, right, which are the health facilities which are very vulnerable. Have we retrofitted the buildings, and can people have access during this during the crisis? And are these ready for emergency response? Are these facilities fit for purpose? So there's a lot of questions can be done with this science here. We are talking about various waterborne, vector-borne, and so we track so much of the information. Initially, we were tracking them at the national level. We've gone down little less now at the first sub-national level, second sub-national level. We're trying to do it at health facility level in few facilities and things. So there is a big gap between decision-making when you have very high-level data, very granular data, rather than mapping the whole district into red, into saying that this pocket is what is red within the district, if that is the case. So that small area estimation is what we like to move. To do that, we need a lot of Earth observation data and other data to support it, right? We cannot randomly do that work here. This other example is on Gaza. Somebody was asking how actually we support Gaza. What do we actually do there? We mapped all the facilities in Gaza. There are 36 facilities. On a regular basis, it means twice or thrice a week, we publish this report internally. What is the functional status of these facilities? Some ground information, satellite information, some information on nightlight, all of them combined together gives us a good picture for various decision-making levels. Even for the trucks to cross and go, sometimes our colleagues are saying it takes 3-4 days to go there. So where is our truck actually stuck is one question. It's a GIS question. But at the same time, to know, is there actually a facility which exists there? There were a period of time the communication was totally cut for the entire world with them. So that sort of scenarios, we actually use satellite imagery to a great extent. Actually, that is a Maxar imagery we used there, pre and post crisis, very simple. Pre and post, comparing regularly over a period of time to see what is the level of impact, how many beds, what is the full capacity, what is the current functional capacity, that sort of information. That is a big information for a frontline worker to have it with them. Another example on the, this one we started with polio. I was telling our colleagues that in polio, actually, how does it come? There's a virus which comes through feces, and the kids play, and then it is spreading from one children to another children, right? The only way to find polio cases is first to find all the paralysis. Any paralysis, you have a spasm, you have any paralysis, they immediately go and collect the sample of that. In many countries right now, they even forgot doctors even do not know how to find a polio case, because it is slowly fading away, but still the virus can be circulating. Then they started getting into this of finding the samples from the sewage and testing it for the virus. So that's a proxy way to find if the virus is still circulating or not. And that's a very powerful method, because in areas where they don't even report that the child has been paralyzed, or they do not even know, or the child dies. After that, there's no reporting even. But this one is a very powerful way it started in 15 years ago. I was very much engaged in that. So one question at the time they asked us, can you help us in the site selection? Which is the right place in a city where the open drains and things are there to collect your grab? That means it's a watershed. There's a lot of GIS parameters come into that so that you could help them. So now what you're doing is we're building a database of all the collection samples in the area of health, so that you know that these are the places where actually they're collecting the thing. And there's a prospects of work going on funded by the Gates Foundation to do the modeling of this work. Okay, there is 1 minute more. So quickly, it's the same thing. It's a drainage or the watershed area for each of the samples. So they say that these are the places where we are collecting. Immediately we do an analysis and tell them if this is the right location. The next one is, I don't know, some people get afraid about snakes and things, right? We help this entity team on the snake bite anti-venom stockpiles. The question that's funded by Wellcome Trust, they asked us, there's only 300 venomous snakes in the world. So we started mapping the habitation of these venomous snakes. Habitation means every snake likes its own temperature, humidity, precipitation, all these parameters is what determines its habitation space. So we mapped all these habitation space, each one of them. Then we started overlaying the case loads. Then we are trying to see from the farthest place to go to the nearest treatment center, how long it will take for them. Because the experts say that if you don't go within 3 hours for this bite, you're done. So then we are trying to see in an online interactive place where this is the first thing we mapped all of them. Then we did ask this public to submit their photos of venomous snakes, which they're taking a photo. It's time up. So 2 more slides. So the similar thing, what we did is we mapped the risk areas and overlaid the population with this and the health facility. And this is a project which is going in 14 countries to say which is the right location for that to have their anti-venom stockpiles. And this might be interesting for the climate change people, that as it gets warmer and warmer, I'm getting pressure here. As it gets warmer and warmer, snakes also move, their habitation moves. So this is how it's going to happen. They're going to come more into the urban areas. See this good example in Australia. So all these red patches where the snakes are going to actually move in before 2050 is what the modeling says. And some areas they are going to move away from there. Yeah, this is the drive time analysis which we are talking about to the health facilities. So it's an interactive app. You put a place for a new facility, then immediately change the old configuration. All the red areas here are underserved for us. Imagine remove one facility from one place and put a dot in another place. It can give you a good sense of where you need to put your facilities. Difference between choice and chance. I would stop here and thank you.